In the late 1920s, the American astronomer Edwin Hubble discovered that the universe is expanding. Such a universe was in fact predicted by Einstein's theory of gravity. But for many years after the discovery, only very simple models could be studied. These models assumed that the universe was the same at all points and in every direction. The models predicted that the universe arose from a singular state of infinite density and infinitely strong gravity. Among relativists working on this problem across the world was a young researcher in Kolkata, Amal Kumar Raychaudhuri. His seminal work showed how a complex universe which was not the same at all points, which rotated and had shearing motions, could be studied. Raychaudhuri's equation provided a simple way to describe these complexities, and the equation has been used by Stephen Hawking, Roger Penrose and others to show that singularities are endemic to Einstein's theory. This equation will stand firm until Einstein's framework for gravity stands. Though Professor A.K. Raychaudhuri received international recognition for his work and continued to make pioneering contributions to gravitational theory and cosmology, he remained relatively unknown outside the scientific world. This is his story.
Well, obviously, I can't remember my birth. But I am told that while my father was a school teacher in Calcutta, my mother went to Borisa, our home district, just perhaps for giving birth to me. And after I was about 1 month old, my mother came over to Calcutta with me. After that, broadly, my life has been spent in Calcutta all through. My teachers had somehow a poor opinion about me. My elder brother, he was also a student of that school. He has a very good reputation about being a brilliant student. So sometimes I found that my teachers wondered, you were his brother. I had that intelligence to understand that what it meant. In Calcutta, I was first of all admitted in a South Calcutta school. It is still there, Tirthapati Institution it is called. And the headmaster was apparently a very strict gentleman, but he appreciated inequality. I can tell you about one incident. He was teaching and he solved one problem in the blackboard. I took courage and stood up. Sir, I think I can do it in an easier manner. He asked me, how can you do that? This is the method. He didn't chide me, rather appreciated, and in the next issue of the school magazine, he put it that Amal of class 9 has suggested this method. Yes, I took it as a challenge. For example, study of algebra, at a stage when study of algebra has not begun in the class, but it will be taken up in the next class, I took hold of an algebra book and went on studying and solving problems. It gave me great pleasure in solving mathematical problems. That was the incentive for doing this. But I went over to physics rather than mathematics. The reason was very practical. At that time, my father told me that you see my fate, that although I got a first class in mathematics, I was not a success in practical life. So, think about studying some other subject rather than mathematics. And that is why I switched over physics. I took admission to Presidency College in 1940 and I passed out my BSc, Bachelor of Science in 1942. That remarkable year, 42. The evacuation of Calcutta, the August movement, and closely following that, the famine in Bengal. Perhaps in late December 1941, we went over to Borisal, and to be frank, with my childlike simplicity, I enjoyed that. There is a thrill that there may be bombs falling and I am going from Calcutta to Borisal, etc., etc. I was not at all disturbed. I was thrilled as far as I can remember. Only on one occasion I have seen my father in tears, and that was that, because the situation was rather bleak as it seemed to him, that practically he has lost his job, and a school teacher does not have much of a saving, a poor saving, and what lies ahead is quite uncertain.
Amal Raychaudhuri came back to Kolkata and completed his BSc examination. As always, he excelled in theory. In late 1945, he finished his MSc. Hoping to support his growing interest in research, he applied for a research scholarship at the Indian Association for the Cultivation of Science. His dream of engaging with theoretical problems faded when he was assigned the unfamiliar role of an experimentalist, and he failed to achieve anything substantial. Matters came to a head when, after 4 years of work, Raychaudhuri lost his assistantship.
And I was very much depressed that all these 4 years of my youth have been spent and I have not been able to do anything. I was almost losing my self-confidence that whether I shall be able to do anything at all.
Raychaudhuri took up a teaching job at Ashutosh College to stabilize his financial situation. But wanting to continue research, he approached the mathematician N.R. Sen at Calcutta University, offering to work gratis under his supervision. Raychaudhuri had developed an interest in general relativity and wished to explore it further. Sen was not enthusiastic, but he did encourage Raychaudhuri to publish his first paper in the Bulletin of the Calcutta Mathematical Society. This was a big boost to his confidence. New ideas for study came fast and thick, but Raychaudhuri was frustrated by Sen's conservative approach to research. The only option, it appeared, was to work independently.
So at that phase, I felt that continuation with him is more a hindrance than a help, and I left going to him. I did not tell him anything because I had no obligation. I did not receive any money or anything. I just gave up going to him and produced some papers. that was uh, that was the idea was how, assuming that the universe to begin with was homogeneous, then how can non-homogeneities like galaxies and stars come into being? I could not, did not claim that I have solved this problem, but I believe that I got some interesting results in it. Then came another paper, also published in Physical Review. And the third paper in Physical Review was the paper in which I presented what is now called the Raychaudhuri Equation.
When you look at the force of gravity, the tendency of gravity is to shrink or contract everything inwards, and that leads to the tendency to form singularities, that is when all matter is compressed into a very small volume. And this notion of the Big Bang universe is related to that the Big Bang was when the universe was compressed in a point. Now scientists as a rule don't like singularities, which are very peculiar things which are not consistent with reality. So they were looking for other models where instead of just expansion, you can have rotation and other ways the universe can behave. The work which Raychaudhuri did, which was known as the Raychaudhuri Equation, was to derive a fundamental equation based on Einstein's relativity to show the relative importance of different forces which arise. Gravity on the one hand, then you have rotation which prevents collapse, but he also came to an important conclusion that there is shear which is twisting or moving different layers on one on the other, and it is the shear which helps gravity and rotation which prevents.
So from that point of view, I would say that Raychaudhuri found a way to show that Einstein's theory had a fundamental limitation. That there was some point where you had to say that you couldn't go beyond, you had to go beyond Einstein's theory. Einstein's theory had to stop at some point, and that point is the singularity. So Raychaudhuri's equation essentially established a way, a key way to analyze the problem of space-time singularities.
So he left the subject in a very tantalizing situation. You have on the one hand rotation and the other hand shear. One helps, the other doesn't. So the scientists in the 1960s took over from that early work, and people like Penrose, Hawking, Garrosh derived further conditions for the universe to have a singularity, and to what extent the singularity can be prevented or not prevented. So all this work which came in the 1960s was inspired by the work of Professor Raychaudhuri and the so-called Raychaudhuri Equation.
The equation was born the same year as I was born, so all the sociology associated with the field at that time is not known to me. But I would say that Raychaudhuri's recognition in terms of the sociology of science, of physics, has come in much later than would have been the case, given that this work is so key, so fundamental. And that displeases me a little bit, and I'm sure it displeases many of us a little bit, because my categorical statement again would be that after the pioneering contributions of Satyendranath Bose, Sir C.V. Raman, Meghnad Saha, Jagadish Chandra Bose, the next level is the Raychaudhuri equation.
In 1957, Raychaudhuri received a letter from a friend in Germany that two eminent physicists, Jordan and Heckman, had made references to his work in their latest publications. This was the first real recognition of his work.
Well, I was overjoyed, to speak frankly. And I was now quite confident that I am facing the world and able to give them something. That is, my confidence that was already there rose sky high, so to say, that I can now stand on the same platform as anybody in the world with my limited, of course in my limited knowledge.
In 1960, Jayant Narlikar, a young research scholar working towards his PhD degree at Cambridge, was investigating the physical behavior of a spinning universe. The problem was suggested to him by his supervisor, the legendary astrophysicist Fred Hoyle. Narlikar came upon references to Raychaudhuri's paper and found his equation of great relevance to his own work. When he showed Raychaudhuri's paper to Hoyle, he was impressed and immediately recognized its significance.
I wondered all the time that I would like to meet this gentleman whose name was there, and I was using and quoting his work in my own writings. So the occasion came in the 1963 Texas symposium. In the Texas meeting, there were a lot of relativity people invited, and A.K. Raychaudhuri was invited in that list. And when I saw the name, I said I must go and look him up. I looked him up, and I then told Hoyle, who was also attending, that Raychaudhuri is here. Would you like to meet him? He said, very much so.
Jayant introduced me with Hoyle, and Hoyle, how come you are so young? Later on, I remarked to Jayant that why did he make some remark? This remark he has made previously also. When we saw your paper, he remarked that it is strange that I have not seen any work by him previously. How can it be? Such a profound work must come from a pretty senior person. But now when you found that I am not a pretty senior person, he was surprised and expressed that surprise in words.
Until and unless he got his recognition from the West, in India he was not known. He was not very much known. When he got recognition from abroad, then he was recognized in India. I think this is the custom in our country. If foreigners praise you, then you are great.
What was your first impression of Professor Raychaudhuri?
Very unsmart, but a good student, promising scientist. That was my idea. He never put on these trousers and shirts. Only when we went to USA for 1 year, then we could manage to insist on his putting on this trouser and shirt.
After the Texas conference, Raychaudhuri spent a year teaching at Maryland University.
And the students also were courageous enough. They could remark like that. Sir, I think that Einstein was quite wrong here. In my class in Calcutta, nobody will question Einstein. They will even question some simple things that I present. They will not dare to say that, sir, I think that perhaps you have not noted that there is this trouble.
Yes, 3 times each, like that.
I tried to encourage that spirit among my students. I don't know how far I succeeded. It is very difficult to succeed in these matters.
Even before the Texas conference, Raychaudhuri's reputation as a teacher was growing. After Ashutosh College, he had attempted a second stint at IACS. But this time his interest in pursuing relativity was discouraged by the then director, the great scientist Dr. Meghnad Saha. Raychaudhuri's seminal paper on relativistic cosmology was written during this period. an achievement which is all the more admirable considering the hostile working environment. After a miserable 2 years, Raychaudhuri quit. In July 1961, he was appointed Professor of Physics in the Presidency College in Kolkata. This marked the beginning of a glorious career, devoted to teaching and research. Ironically, when in 1963 he went to Texas, he was better known in India as a teacher than as a researcher.
First choice was to remain in a pure research line, but that became practically closed because of the attitude of people in the ISS. So then it was, I must be a teacher. Yeah, it was good but a painful decision. It was a painful decision because one cannot compare the conditions in a research institute. They are so favorable for a sincere research worker compared to that in a college.
Raychaudhuri spent 27 years at Presidency College, teaching and inspiring several generations of physics students. This period was considered a golden period in the history of the college's physics department. The best young brains were drawn to it, eager to learn pure science with its renowned teachers, who counted among their numbers Shamal Sengupta and Raychaudhuri.
There could be two kinds of teachers. One is after one finishes his course, you will learn to do something by your hand. You learn to work it out yourself. The other, who does not bother very much about the formalism, but can inspire you so that you can take up the subject by yourself. But this Raychaudhuri's course was a perfect blend of both, I would say.
One part of my job as a professor of Presidency College included guiding the students in the laboratories. I did not, frankly, I did not enjoy that part. That part appeared to me very boring, and perhaps I was not very helpful also to the students. But so far as the theoretical part is concerned, I enjoyed that very much. It was, in a way, not only teaching students, but expressing myself. That feeling was there. And expressing myself in a way which was somewhat novel, not in the textbooks.
Teachers are mostly they transport materials from textbooks to the classroom, like porters do luggage, like that. But only a few outstanding teachers are there who really digest a subject and recreate it playfully or in a delightful manner.
We were in the first batch. He actually came to teach in Presidency College, Calcutta in 1960. He has, over the period of 30 years, produced generations and generations of theoretical physicists from the Calcutta area. Many of his ex-students are very, very well-established physicists all over the world. He was so unique that we thought there was something special about this person, and so we had people following him. What does he do? I mean, he used to live in Old Baliganj in those days, and he used to come by tram to Presidency College and get down from the tram. He used to wear a dhoti and a kurta, and the concha of his dhoti he will tuck in his pocket and then walk to class. But some of us found out that there was a chanachur wala who used to stand near the tram stand, and he would buy chanachur from him and eat. And we thought there must be something special in this chanachur. Well, that's the source of his brilliance. We all rushed to the chanachur wala and started buying chanachur from him. And till my last day in Presidency College, I bought chanachur only from the chanachur wala. And I feel that whatever small amount I have done in my life, I owe it to the chanachur wala.
When we started general relativity, he cited this example that if you go to the Goriahat crossing, you have a tram line. And suppose you have a tram car waiting there, and if you ask a mathematician what will be the trajectory of a tram car, of this particular tram car, the mathematician will say that I can give you the answer, because But I need the force on the tram car, and I need two initial conditions because Newton's law P is equal to mf is a second order differential equation. So give me the force and give me two initial conditions. I shall give you the solution. I shall give you the trajectory of the tram car. But if you ask a rickshaw puller what will be the trajectory of the tram car, he will be surprised. He will say that the tram lines are there, so the tram car will follow this tram line. And this is exactly the philosophy of general relativity. We find out the geometry of space-time, and given the geometry of space-time, a particular particle will follow that trajectory by itself. So this kind of examples he used to use in those days.
All of us, all of my batchmates, were always respectful of him because of his excellent teaching. Not only that, the manner in which he liked to interact with us. He had a very small cubicle where he usually took rest. Anyone could intrude anytime there with any problem, any question. I never saw him become irritated.
Teaching has also another part, that you have to go back to fundamental physics or elementary physics. And going back there is not a fruitless thing. Every time you go back teaching something fundamental, so something fundamental like, say, as per Newton's laws of motion. They are very, very old thing. But even when you go back to that, you find something curious thing that this is hidden within these laws I had previously noted. That gives you great pleasure. Thank you, Oshit, for introducing me. That will be rather a curious word, because I believe that I am quite well known to all of you. Today, I will say a few words on rotating perfect fluids in general relativity. Rotating, that is a very disturbing problem. Another is so beta must be independent of time. Have I reached senility? I don't know. Perhaps a degree of senility prevents me from making further calculation, or at least makes that extremely difficult, so that I have not been able to proceed further. But I believe that
teaching is very important for me as well. I am not as gifted as Professor Raychaudhuri. I mean, anybody will not be a Professor A.K. Raychaudhuri. That should be taken for granted. That is obvious. But the thing is, when I was a student, I got a lot from them. Professor Raychaudhuri, and also some other teachers. So now I feel that it is my duty to give something back to the community. So it's always there, his inspiration and the fact that my life is full with them. I cannot repay everything back, but I should always try to give something back to the community. So definitely he inspired as a teacher as well.
Well, an academician's activities include this: teaching students, then writing some good books, both in his research field or in teaching field, and then guiding young people in research work, and also doing some guiding young people does not mean that you should yourself do nothing but simply boss it over. Doing some research work himself. I would say that I would place me in the B class, at most in the B plus class, not in the A plus class. My senior friend, Professor Vaidya, made a nice remark. We have retired in the sense that at the end of the month, we don't get a salary check. But otherwise, we have not retired. He might add that we are not taking the routine lectures, that was part of our duty. But otherwise, that is making our own studies, thinking about problems, doing some problems if I can. That continued more or less up to say 2 or 3 years back. In the last 2 years, I am not being able to do anything. This was perhaps the last big paper that I produced. It was published in 2004, in February 2004. It is a pretty big paper, and I think it is important. That is my assessment. For the works that are presented here, the author is solely responsible. There having been hardly any consultations with others. However, in a wider sense, he feels indebted to many who in different ways have fostered in him the spirit of inquiry and given him sustenance and hope, without which no work is possible. And lastly, he feels glad that the universe, whether evolutionary or stationary, nevertheless exists and thus makes possible the author's dabblings and delvings. So I am glad that I can make these dabblings and delvings.
I was born in 1918. My father was in the post office. My father died in 1931. I was 13-year-old at that time. My elder sister has just married.